Hello everyone, so I am going to talk about our data analysis for the final project. Um, and the topic is about house prices in Iowa. And our group members consist of Asaf, Jacob, Anna, Blake, T sharing, and me doing. So about the data set, um, we pick a house price data set from Kaggle. The dataset consists of 79 explanatory variables describing every aspect of residential houses in Ames, Iowa. And the libraries and packages that we use in this project includes for data manipulation and loading, we use Pandas, NumPy, and for data visualization, we use Seaborn and Matplot library. uh, the first thing we do, the first stage in our um, process of analyzing the data is loading. And as you can see, our data set have 1,460 rows and 80 columns. Within 80 columns, there are 79 explanatory or independent variables and one dependent variable, which is the sale price. So when looking at data, we also look at other part like and try to understand different aspects of the data. The first thing is identify. We identify the data types um, to, to allow us to figure out whether we want to correct the data type or not. So it's important to know the data type to which each column currently belongs. At the first time when we load the data, uh, the pandas will look at the data and try to assign the data um, with a type. It will see number and it assign number to either float or integer, and it will see some data that are contains characters. It will assign the data to object string. So sometimes we may want to convert numerical data to categorical data and vice versa. So it is important to know which data type that the column is currently assigned to. And also, like when knowing the data type, we um, for categorical column, we cannot apply calculation on them. And for numerical columns, we can do some calculation, manipulation. Thus, it's important to identify which columns are categorical and which column are numerical. And so next, so we have some code over here that help us identify which columns currently are current object and which column are currently integer or float. So as you can see, the zone, the street, the alley, the lot shape, the land contour, the utilities, the lot configuration, the land slope, the neighborhood, the condition, they all now are string, thus they of the type object, and they are categorical data. And as you can see in the over here is the numerical data. Now we have the subclass, the lot front edge, the lot area, the overall quality, the overall condition, the year built, the year remodel. As you can see, the overall quality, the overall condition, the year built, they are not numerical data. They are not um, numerical data, they are categorical data. Uh, Overall quality is categorical data, and we cannot apply any calculation on them. The um, mean, sum, median have no meaning if we apply on the categorical data. thus it's important to identify, and later on we may want to convert them into categorical data. And also we need to identify missing values that allow us um, to know which column have missing values, and then identify how are we going to deal with the missing values. So we first create, like, count how many number of the missing values in each column, and then we perform Boolean indexing to retrieve columns that have the number of missing values greater than 0, and the result shows us all the columns that have missing values. And next, so the next step is the cleaning the data. After we viewing the data set, we identify the data types that each column belongs to. We identify which columns that we have, the type, and then we identify the columns that have missing values. Now we can do some cleaning, and there are two main cleaning tasks that we have done on our data set. First, we map categorical values into their corresponding values of a more descriptive format. I will discuss later what does this mean, but in general, you understand that we do some mapping from one value to another value in this task. In the second task, we filling missing values with we're filling the missing entries with appropriate values. So in the first step, for example, we have this column MS subclass. MS subclass identifies the type of dwelling involved in the cell. For example, we have, and currently this column contains only numbers, and each number corresponds to a type of dwelling. For example, a record that has this column value 20 belong to the first story, the type of first story 1946 and newer old style, or the houses that has the value of this column is 90 belongs to the duplex house, belong to houses that duplex. So in modeling and predicting, we prefer to turn our data to number. However, the objective of this project is not predicting. We are not creating the model, so but just analyzing. So we decided to map the numerical values to their corresponding text representation. Um, like we will map those number to those the meaning of those number. So there are several advantages of doing this, so we decided to do this. For example, the data we have in our dataset will be more descriptive. When we read, we can understand what they like. When we look at this, we can understand what they mean, and we can better doing the analysis. And the second thing is that uh, we will not misuse. I mean, we will not perform numerical calculation during an analysis. Since numerical calculations such as mean, median, sum, mode apply on categorical data have no meaning. In this case, if we apply mean on those values, there is no meaning. The result is have no meaning, has no meaning. So the next, so so in this, so as you can see, here we perform the mapping. We map those number in this MS subclass column with those values, and at the end, this column only have those values that are more descriptive and they are categorical data. We also in our dataset there are a lot of columns that contain abbreviation, like the abbreviation RH, which means residential high density. So we also decided to map them to their actual values. Is it also depends on the preferences. You may choose to keep the abbreviation, but in our group, we decided to map to the actual values because this ambiguation of the values may hamper our ability to understand the dataset because it forces us to look up the values in the description.txt file from time to time to understand what an abbreviation means. So we decided to just convert all values that are vague to values of a more descriptive format. Um, so at the beginning, for example, we have this column, building type. At the beginning, the building type column have those values. And if you just look at this at the beginning, you wouldn't understand what what they mean. So we decide to map those values to the descriptive form using the map function. And also during the process, we also fill the missing values with the unknown value. And at the end, we have the following values. Our the column building type had the following values. And so after applying the mapping process and filling the missing values on these categorical columns and following are the remaining columns that have missing values and we have to work on them. So because linear fit of street connected to property this column lot frontage linear fit of street connected to the property and this column mass veneer area in square feet are numerical data. We decided to fill the missing values with the mean value of the columns. um, it also depends on the distribution of values in the column to decide whether to use mean or median, whether to fill the known values with mean or median. If there are so many outliers in the column, median may be preferred since outliers affect the mean value. The mean value is skewed by the outliers. So in this step, in this stage, we decided to fill the missing value with the mean value. And also here we have the year. Currently, year is number. The year column in our data set, the year columns like year built, year sold, garage, year built, they are numerical data. They are currently number, integer. And we may want to convert them into categorical data or basically string. And what we can do is that we can use the S type to convert the column to the string. However, we decided to keep the values as number since we later can use function like cut or quick cut to convert the years to group of years ranges of the year range by sorting data values into different bins. Um, so after we have do some basic cleaning, mapping values to their actual values and filling missing values, we comes to the next part, analyze the data. So analyze the data, the first part that we want to dig in is showing the relationship between the zoning classification and the sale price. So we have different zone We have the residential medium density zone. We have residential high density zone. We have residential low density zone, and we have floating village residential. So first, we want to group the cell by the this column MS zoning and apply the describe method to each group uh, to get the price statistical description for each group. So we have the cow, the mean, the standard deviation, the mean to each group. And then we plot a box plot to better understand the distribution of sale price for each zoning type. And we use box plot. It's very helpful because you can observe different aspect, or you can observe the distribution of all values belong to the to each group. You can observe the mean, the median, the mean, the max, the range, the median, the mean, the 25th percent, the 75%, and you can compare the distribution for each group. And it's very nice to use the box plot in our perspective. And you can also observe outliers using box plot. So we draw some observation from our aggregation data and from our plot. So most of the houses in the dataset belongs to the residential low density. As you can see, we have out of 1,460 record, we have 1,000 that are residential low density houses. And we only have a few record that belong to residential high density residential high density. The second observation is that houses that belong to the floating village residential, this blue, are always high. Like most of them are high. So in our dataset, we have 65 records that belong to this, and the mean price of this group greater than $150,000 compared to other types of zone. Um, the third observation is that the price distribution of the residential low density is more variable. We have houses that belong to this type that are very cheap, houses that in the medium range, and some houses are very expensive. And if we compare, um, we can see that floating village resident may be greater than residential low density, greater than residential medium density, and greater than residential high density. Um, the second stage of our analysis, we focus on the relationship, we focus on the physical location and the sale price. For example, if I go to some place and I don't really know about the place and I want to know which neighborhood that often offer lower sale price, it's very convenient if I know which neighborhood that often have lower sale price. I just come to visit that neighborhood, contact with people in that neighborhood, um, to try to find a house. And so in this analysis, we do some aggregation and we to get the statistical description uh for each neighborhood in terms of sale price. And we also draw box plot to view the values distribution for each neighborhood. And so as you can see, different neighborhood has different price distribution. Some neighborhood have lower price distribution and some neighborhood have higher price distribution, such as some have very high price. Some neighborhood have very high price distribution are um, Timberland, Stonebrook, Northridge, Hyde, Northridge, and some neighborhood offer more affordable prices, such as Brookside, Edward, as you can see, Brookside, Edward, Old Town, say Sawyer. And if I want to find some house that offer more affordable price, I can go to those neighboring neighborhood and is give me the better chance to find houses that offer much lower price. And of course, we also consider other aspects. Mm, so next, we want to identify the relationship between the quality of the house and the sale price. Um, we also apply the aggregation and also using box plot for visualization in this analysis. And as you can see, um, good overall quality would cost me an average of $200,000, and a house that has very excellent overall quality would cost me double, an average of $430,000. And also, um, as, as you may expect, the higher the quality, the higher the price is. As you can see, in terms of overall quality, when we sort the overall quality, the we also can see that the sale price distribution also decrease as the overall quality decrease, and also external quality also shows that as the external quality decrease, the house price decrease. Next, we look at the house size and the sale price. Because the dataset does not provide us the total areas of houses, we must calculate the total area by adding the areas of individual ones. So we sum up the areas of the first floor, the second floor, the living area, the garage, the basement, the pool, the wood deck, the porch, that, and then we calculate the total area. Then we draw a scatter plot to demonstrate the correlation between the house area and the sale price. And as you can see, the data point and the regression line show there is a strong positive correlation between the house area and the sale price. As the house area increases, the sale price linearly increases as well. Um, Next, we want to look at the year of construction, or in other words, the the age of the house, the new of the house, the new level of the house, and the sale price. So the two independent variables that we care about in this part are the year built. The year built is the year that the house were constructed, and the year remodel, the year the house were remodeled since they were built. If the year were not remodeled, the construction year would be equals to the remodel year. So following we have those year the years in our data set that houses were built, ranging from 1872 to 2010, and those are following years are the years that houses were remodeled, ranging from 1950 to 2010. Um, so we will not work directly with those years. Instead, we cut the year into different period based on we cut the data into different periods based on the year built. Um, That's why we didn't convert the year from numerical value into string data type, because we want to be able to cut. And in order to cut the data, we have to leave the year column as number, so that we can cut the data into a range of years using the cut version. So we have different period from 1872 to 1913, the period in which uh, houses were built. And we have this period 1913 to 1927, and we have 122 houses were built in this period. We have 1927, 1941, we have 98 houses in this dataset were built in this period, and so on and so forth. So um so we apply we group by the period the house were built, and we apply the describe method to obtain the statistical description of about the sale price for each group in terms of the year, the period the houses were built. And we also draw a box plot for this analysis. And there there are two observations that we made. As through the middle line of the boxes, as you can see, the mean increases as the level of recency of the house, like the more recent the house were built, the higher the price seemed to be. And also, uh, considering each period which how in which houses were built. As you can see, each of this period we have outliers. Like this period have outliers, this period have outliers, this period have sale price outliers, this period also have. So houses, every period there are houses that are much more expensive than other houses that were built in the same period. So there are also other factors that affect the house's price other than the year that the house were built. Um, Next, we want to examine whether remodeling affect the price, whether remodeling the house increase the the sale price. Of course, it does, but we will look at the data set and reassure that assumption. So we have the two columns, year built and year remodel. By doing the comparison, we can know whether the house has been remodeled or not. If the year built equals to the year remodel, that means the houses has not been remodeled and the value is false. If the year built is different from the year remodel, that means the house has been remodeled and the value is true. And so we have generate a new column called has been remodeled. And in this data set, we have 6 out of 1040 houses, or 400 houses. There are 696 houses have been remodeled. So does remodeling affect the house price? So we have used the factor plot from Seaborn to visualize the data. So how does Seaborn obtain this? How does Seaborn plot this chart? So First, Seaborn grouped the data based on the two independent variables. It first grouped the data based on the period that the house was built, and then within each period, it will group to two other groups, whether the house has been built, has been remodeled, and whether the house and when the house is not has not been remodeled. And then it takes the average of the sale price for each house group. So for example, this data point is the average sale price for houses that is in the period that were built in this period 1872 to 1913 and has been remodeled. And as you can see, there are two observations that we made. All houses from 1872 to 1941 were remodeled sometime in the past. They all remodeled sometime in the past. And those houses that were not remodeled in the period from 1955 to 2010, they have lower price than those has been remodeled and were built in the same period. Those that are were built in the same period, but they have higher price because they has been remodeled in the past. Um, Next, the final analysis we look at um the of trend of using exterior materials covering on house in different period of time. Whether the taste of choosing exterior materials covering on house different period of times, change over time. So we use the cross-tab function. We first count the number of houses for each type of exterior material within each period. For example, we have this period um, in this period from 1872 to 1913, there were 7 houses having asbestos shingles as the covering material. Here we do cross tab the columns exterior first and exterior second. Seeing a house can be made from using two exterior materials. So the table show that some materials will used more often than the others, such as as you can see, the hardboard, the metal siding, the vinyl siding, the wood siding. They were used more often than the others, such as like as for singles, they are not used a lot. They were not used a lot to build houses. And we draw a stack bar chart to um and then draw some observation. So as you can see, the cinder block, this material, were used during 1872 to the 1969. They use like like almost 50% or maybe 25%, and then people rarely chose it afterward after that after this year from and the most recent build has like from 19, 1969 to 2010 were no longer using it. About the metal siding, which is the this green yellow color. This one were used, as you can see, were used in all the period of times, but before during the earlier period, you can see in the earlier period they were used a lot from 1872, from this period to this 1969, and then they also you use less after that. The hardball, the pink one, they were not used during the earlier period. You can see this. They were not used in the earlier period, but then they was preferred during night from 1955 to 1969. They were preferred to build house. The pink one, the hardball, and the brick face, the red one. They were used in all period of time, but was only preferred recently. Most houses built in 1996 to 2010 made from brick face, as you can see over here. And so, in a conclusion, in this project, we have applied our knowledge that we learned from the class, include how to work with data cleaning, data aggregation, data visualization using NumPy, Pandas, Matplot, Library, Seaborn, on analyzing the house price dataset. So there are three main stages that we have performed: loading data, clean data. In cleaning the data, we correct data, we map the values that, not that the values are incorrect, but we map those values that range um, to more descriptive data. The second task we have done in our cleaning task, we deal with missing values. Um, in the second stage, the main stage, we apply some analysis method on the dataset. We do data aggregation and we do the visualization. Uh, some key takeaway is that box plot is nice, since we can observe the distribution of the data, the mean, the median, the max, the mean, and the outliers. And also, visualization is so important in data analysis because it can uh, tell us about stories and insight from the data set. And also in this analysis, we also have we have generate new columns that allow us, for example, we generate the column period in which houses were built. Using the cut function, we also generate the total area column. We also generate a column has been remodeled or not, in order to allow us to um, more effectively analyze the data, get the insight from the data set. And this is the end of the presentation. Thank you for listening and have a great evening.